All right, in this video, we're asked to draw the complete orbital energy diagram for a selenium atom. So for these orbital energy diagrams, I'm going to go ahead and label my axis. So this is going to represent energy. And then I'm going to draw in my orbitals. And so selenium is number 34. So it may help if you take a look at the periodic table to see where selenium is. Unfortunately, I can't show the periodic table and draw the orbital energy diagram here at the same time. But we can see that selenium is in the 4p part of the periodic table. And in fact, it has 4p electrons. So everything up to that is going to be occupied, right? So I start out with the 1s orbitals. Then I have the 2s. Then the 2p's. Then the 3s. The 3p's. The 4s come next. Then the 3d's. And then finally, I have the 4p's. Right? And so notice that for many electron atoms, the orbital energies depend not only on the n quantum number, but also the L quantum number, right? So the 2p's are higher than the 2s's. The 3p's are higher than the 3s. The 3d's are higher still, right? And recall that to get the ordering correct, we need to use the periodic table, right? So we fill the 4s's before we fill the 3d's. So the 4s's have less energy than the 3d's, and the 4p's come next. So selenium has everything occupied up until the 4p's. So when I fill in my electrons, I fill them into the lowest energy orbitals first, right? And each orbital gets 2 electrons, but one goes in spin up, the other one goes spin down. That's why I drew my one arrow was pointing up, the other half arrow was pointing down. So the next 2 electron goes in the 2s's, then the 2p's. Right, recall when I have these degenerate orbitals that have the same energy, everybody gets 1 electron with the spin pointing in the same direction before anybody gets 2. And then finally get to the 4p's. And if you look at selenium, in the p block, it's in the 4th column, so it has 4p electrons. So 1, 2, 3, and then finally I pair that 4th one. And so if I ask for the orbital energy diagram for an atom, this is what I'm looking for.